Okay, and welcome back to 1.2. I mentioned at the end of 1.1 that 1.2 is just applications of linear equations, kind of practicing some modeling, some exploration of things that linear equations can do. The things that we're able to do at this level, not a whole lot. We don't have a whole lot of tools, a lot of things. So our scope of what we can explore right now is kind of small, but just know that as we move forward, there's a lot of different things that these equations can do for us. So let's just look at a whole bunch of different examples of linear equations. So as a preface, all of these problems are very different. There isn't like a very set way of solving any one of these. It's kind of a little bit of thinking on our own, not so much like actual linear equations where, get x by itself, subtract or add a number, divide or multiply by some number. Modeling in general is just kind of like thinking on your own. The only thing I can tell you is that if it helps you, draw a picture. But in most cases, you don't really need to do that. I shouldn't say that. In a lot of cases, you may or may not need to do that. So whatever works for you, by all means, you do it that way. But okay, let's just do a whole bunch of examples. Let's say a new refrigerator is on sale for $3,000. I have no idea if that's a normal price for a fridge, but let's pretend it is. So let's say a fridge is on sale for $3,000. If the original price of the fridge was reduced by 20%, what was the original price? We know the sale price and we know the reduction, but we don't know the original price. Okay. If the fridge was reduced by 20%, that means that we're paying 80% of the original price, right? 20% off doesn't mean we're paying 20% of the original price. It means we're paying 20% less of the original price. So if we have a 20% discount, it means we are paying 80%. Okay, well, if we say that X is the original price, we don't know what X is, but if X is the original price, then 0.8X is the 80% of that original price. So decimals and percentages, right? 80% would be 0.8. 8% would be 0.08, right? Practicing some percentages, right? That should sound familiar from a while ago. But yeah, so if X is the original price, then the sale price is 0.8X. Or again, 20% off the original price. Well, the sale price that we're given is 3,000. So if the sale price is 3,000 and 0.8X is the discounted price, then 0.8X equals 3,000. Well, we know how to solve for this. Divide both sides by 0.8 and we get 3750. So I know it might be kind of tempting to find 20% of 3,000 and then add it, but that's not correct. Because if you were to go backwards and take that new price that you came up with, 20% of that price is not the discount that we're looking for. So our original price is $37.50. 20% of $37.50 would be $7.50. So $7.50 off $37.50 would be $3,000. So please be very careful when we're practicing modeling these things. Okay, let's say that fridge was never reduced. What is the cost of the fridge, including tax? So I don't know where you're watching this, but let's assume tax in your state is a cool 6%, I guess. So if the fridge originally cost $37.50, we need to pay 6% tax on that $37.50. Okay, so we're paying the cost of the fridge plus tax on that fridge. Okay, so that means our total price is the cost of the fridge, $37.50, plus the cost of tax on the fridge, which is 6% of $37.50. Okay, well, 6% of $37.50 would be $37.50 times 0.06, right? 6%, 0.06. Okay, now this is going to be kind of weird because you could simplify this right away, but there is a little bit of a method to the madness right here. If they both have $37.50, can we factor out $37.50? Yeah, we sure can. If we factor out $37.50 from $37.50, we're left with 1. If we factor out 3750 times 0.06, we're left with just 0.06. Well, 1 plus 0.06 is 1.06, and 3750 times 1.06 is 3975. So, assuming the fridge was never reduced, the total cost of the fridge with tax would be $39.75, including tax. So an extra $225 in just tax. So the reason why I wanted to show it to you this way is because I think it's kind of important for people to know how to calculate tax and total cost of items, right? You go to the store and it's like, this item is $39.99, and then you get to the register and it's a lot more than $39.99. Okay, maybe not a lot more, but it's more than $39.99. So in general, if you want to find the total cost of an item, you always multiply that item by 1 plus whatever that tax rate is in your state. So again, if your tax rate in your state is 6%, if you multiplied every item by 1.06, you have a really good idea on how much you would be paying for that item. So just a interesting thing you can do going forward. Or if you're trying to find like, I don't want to spend more than this, including tax, you can use that to your advantage. So we move on. A student wants her exam average to be an 85. On her first 4 exams, she got a 72, a 90, an 80, and a 67. What score does she need on the 5th exam to bring her exam average up to an 85? Okay, well, the average of her 4 exams would be adding those 4 exams together and dividing by 4. Okay, but we want the average of 5 exams, but we don't know what that 5th exam is. Well, that's not a big deal. All we want to find is the average of 5 exams, but if we don't know what that 5th exam is, why don't we just call it X for right now? So we would add those 5 exam scores and then divide by 5. Okay, but she wants her average to be an 85. So average will be 85. And would you look at that? This is now just another linear equation, right? X to the first power, linear. Okay, well, let's solve for X. Let's add 72 plus 90 plus 80 plus 67. That is 309. Well, we don't like fractions. Let's get the fraction out of here. So let's multiply both sides by 5. 5 times 85 is 425. 5 cancels out that 5. And now we can subtract 309 on both sides to get 116. So this student would need a 116 on her 5th exam to have an 85 exam average. And if we're assuming that every exam is only 100 points, it sounds like she will not be able to get an 85 average because you can't get a 116 on a 100-point exam. Okay. A equals P times 1 plus RT is the simple interest formula. And of these variables, P is the principal, the original amount you invest. R is the rate in decimal form, right? Like 6% would be 0.06. T is your time, which is usually in years. For this purpose, it's going to be in years. And A is your final amount. So if you start with some amount, you multiply it by 1 plus the rate times time, you get the final amount that you would have in your account afterwards. So let's say the account had 4440 in it after 4 years. Not put in 4440, it had 4440 after these 4 years at a rate of 12%. How much money was originally invested? Well, let's plug in everything that we know. A equals P times 1 plus RT. We're told that the final amount is 4440. We don't know what the principal is. We don't know how much money is initially invested. We're trying to figure that out. The rate is 12%, which would be 0.12, and the time is 4 years. Okay, well, all we need to do is solve for P. Okay, well, 0.12 times 4, 0.48. 1 plus 0.48, 1.48. And now we can just divide both sides by 1.48 because this is P times 1.48. 1.48 cancels out. 4440 divided by 1.48 is $3,000. So if you start with $3,000 in an account that pays 12% interest for 4 years, then your total amount at the end would be 4,440. Lots of fours going on here. Okay, another example, right? Kind of hodgepodge there, a little all over the place. Find the length and width of a rectangle whose perimeter is 64 feet. Let me get my camera out of the way. Whose perimeter is 64 feet and the length is thrice the width, then minus 4. Okay, well, the perimeter of a rectangle in general is always given by 2 length plus 2 width. Okay, think back to when you first learned shapes. Perimeter equals 2L plus 2W. Okay, but we're saying that the length is thrice the width, then minus 4. That means the length is 3 times the width minus 4. So 3 width minus 4. Well, if P is 64, then let's plug in everything we know into this equation. P is 64, L is 3W minus 4, and now it's a linear equation for us to solve for W. Okay, let's distribute 2. Let's combine like terms. Let's add 8 to both sides. Let's divide both sides by 8, and we get that the width is 9. Now, that's not the end of the problem. We want to know what the length and width of this rectangle is. We have that the width is 9, but the length is given by 3W minus 4. Oh, we're using that equation that we started with. Well, length is 3 width minus 4. Width is 9. So 3 times 9 is 27. 27 minus 4 is 23. So the dimensions of our rectangle are 23 by 9. If we wanted to double check for ourselves, perimeter is 2 length plus 2 width. 2 times width is 18. 2 times length is 46. 18 plus 46 is 64. Alrighty, here we go. A group of office workers found that their salary can be modeled in this way, that their salary is 60,000 plus 700x plus 1850y, where S is their salary, X is their years of interning, and Y is their years of work experience. If one worker has been working for 2 years and makes 70,000, for how long did he intern? Okay, let's just plug in all of the information that we're given. We're told that this worker makes 70,000, so their salary is 70,000. 60,000 is constant. We don't know how long they interned, but we do know that he worked for 2 years. So Y is 2, right? Y is their years of work experience. They've been working for 2 years, so Y equals 2. Okay, and now we're just solving for X again. Let's multiply 1850 times 2. That's 3,700. Let's combine 60,000 and 3,700 for 63,700. Let's subtract 63,700 on both sides. And let's divide both sides by 700. So after 9 years of interning, 2 years of work experience, this employee makes $70,000. I don't know if 9 years of interning for $70,000 is a good deal, but so it goes. Alrighty, last example. This is a very popular question. It pops up quite a bit. There's another way of solving it if we use a section in chapter 8, but we're not in chapter 8. We're only in chapter 1. So let's see how we can do this. A store sells almonds for $4 per pound and peanuts for $2 per pound, but they want to create a 10-pound mixture that sells for $32. So how many pounds of each nut should they use? Okay, well, let's say that X is the pounds of almonds in the mixture. We have almonds, we have peanuts. Let's say X is the amount of almonds that is in the mixture. You could also let X be the amount of nuts, but it's going to end up being the same thing. Well, if we have X pounds of almonds and the entire mixture is 10 pounds, then there must be how many pounds of peanuts? This is kind of a weird question. It's probably the hardest part to the question, aside from actually setting up the cost equation. But if there are X pounds of almonds and there is in total 10 pounds, then there must be 10 minus X pounds of peanuts. So in total, there would be X plus 10 minus X pounds, right? The pounds of almonds plus the pounds of peanuts. Well, X plus 10 minus X, X's would go away and we would get 10. So we know this makes sense. It's kind of weird that we're letting the amount of pounds be 10 minus X, but all it's saying is whatever space that we still have under 10 pounds is going to be dedicated to peanuts. If we have X pounds of almonds, then we have 10 minus the pounds of almonds for the pounds of peanuts. So it's kind of a weird way of thinking. I get it. We continue. Okay, well, if the almonds cost $4 per pound, then the cost of almonds would be 4 times X, the cost per pound times the number of pounds, or just 4X. If peanuts cost $2 per pound, then the cost of peanuts would be cost per pound times the amount of pounds of peanuts, 2 times 10 minus X. Here, we can distribute 2. 2 times 10 is 20. 2 times negative X, negative 2X. And then our cost equation would be the cost of almonds plus the cost of peanuts equals the total cost of the mixture. And what is the total cost of the mixture? Oh, it's 32 pounds. From here, now we're just solving for X. Okay, let's just drop those parentheses. They don't mean anything there. Okay, let's combine like terms. 4X minus 2X is 2X. Let's subtract 20 on both sides. Let's divide both sides by 2, and we get that X equals 6. So that means that we have 6 pounds of almonds in our mixture. Okay, well, if there's 6 pounds of almonds and the entire mixture is 10 pounds, then there are 10 minus 6, or 4 pounds of peanuts in the mixture. Okay, so you want a $32 mixture of almonds and peanuts. You need 6 pounds of almonds and 4 pounds of peanuts. So, yeah, very, very weird section. There's a lot of random information in 1.2, but that's kind of the idea. So lots of information, kind of take them piece by piece. And with that said, we're going to change gears completely in 1.3 and talk about quadratic equations, which if you're already looking at the screen, maybe just a tad scary, that thing right there. Don't worry, we're going to handle this thing together. So I will see you in 1.3. Bye.
Hi everyone, thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leswowska Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.